Welcome to this video on sequential circuits in digital electronics. We will explore the fundamental concepts of the D flip-flop and the T flip-flop. Let's begin with a quick recap of the flip-flop concept. A flip-flop is a memory element that securely stores one bit of binary data, either a 0 or a 1. It is controlled by a clock signal, meaning it only updates its stored value when triggered by a specific clock edge. This makes it a core component of sequential logic, as its current output depends on its previous state. The D flip-flop, where D stands for data, is widely used in modern computing. It is characterized by having a single data input and following the rule that the output directly follows the input at the next clock tick. This simple design captures and stores data efficiently, eliminating the complex, quote, invalid state found in other flip-flops. This is the block diagram for the D flip-flop. It features the data input, D, and a clock input, CLK. The outputs are the normal Q and its complement, Q prime. The triangle symbol on the CLK input indicates that this flip-flop is edge-triggered. The D flip-flop's truth table shows that the next state, Qn+1, depends solely on the data input, D, when an edge is detected on the clock. If the clock is low, no change occurs, regardless of the D input. When a clock edge is detected, D equals 0 results in Q of n+1 equals 0, and D equals 1 results in Q of n+1 equals 1. The operation of the D flip-flop is straightforward. On the clock edge, the output equals the input, meaning the value at D is sampled and locked into Q. The characteristic equation Q of n+1 equals D clearly shows that the next state is exactly the input data. This simple design successfully eliminates the undesirable invalid state. Next, let's look at the T flip-flop, where T stands for toggle. This flip-flop is heavily used in digital counters and timers. Like the D flip-flop, it uses a single input, T. If T equals 1, the output toggles, switching its current state to the exact opposite. The T flip-flop block diagram shows the toggle input, T, and the clock input, CLK, along with the normal and complemented outputs. Notably, the T flip-flop is commonly constructed by connecting the J and K inputs of a JK flip-flop together. The T flip-flop truth table reveals that the next state, Q of n+1, depends on the T input and the previously stored state. If T equals 0, the output holds its current state. If T equals 1, the output toggles or inverts on the clock pulse. This characteristic is what makes it ideal for counters. Let's examine the T flip-flop's operation based on the T input. If T equals 0, the flip-flop acts as a standard memory, holding its previous value. If T equals 1, it toggles, flipping a 0 to a 1 or a 1 to a 0. The characteristic equation Q of n+1 equals T XOR Q of n shows the next state is the T input XOR the present state. Here is a comparison of the D and T flip-flops. The D flip-flop passes the input directly to the output, making its equation Q of n+1 equals D. It's primarily used for data storage and shift registers. The T flip-flop reverses the current output if T equals 1, with its equation being Q of n+1 equals T XOR Q of n. It's primarily used for counting and frequency division. Both flip-flops have essential applications. D flip-flops form the basis of registers and memory units, like SRAM. T flip-flops are used in counters and frequency division circuits, as toggling halves the clock frequency, a key feature in many digital systems. In real-life electronics, T flip-flops are used in digital scoreboards and timing circuits for CPUs and USB ports. D flip-flops are crucial for shift registers in devices like USB drives to sequentially move data. In summary, the D flip-flop stores data by copying the input to the output, while the T flip-flop toggles the data state when activated. Both are sequential core components essential for building modern counters, timers, and processor memory.
Thank you for watching this video. Keep learning and keep growing. If you found this video helpful, please like, share, and subscribe.